All right, physical science students, consider this to be kind of like notes, maybe. Like we would have had this conversation in class together, but we're obviously not there. Now, maybe you can see here and notice that right here, this right here, this you already have. This is actually from the top of Worksheet 1, Unit 3, Worksheet 1. If you never actually did this, maybe you should take a look at that. But this is literally from the video that I posted. I took an image from that, and then I kind of cropped it because there was actually 5 graphs here, but I cropped 3 of them in this one, and then I created VT graphs here below each of these, and motion maps up above here. So here's what the goal is. All right, and I hope that you have some paper in front of you, preferably the actual worksheet that this came from, that you can write on. If you have the hard copy of it, which I gave you that day in class, which was March 13th, Friday, March 13th. If you don't have that, then I hope you'll at least have your comp book out, and maybe you'll write some of this stuff down in your comp book. But here's the goal, all right? The goal is that by looking at the position time graph, you will be able to figure out what the VT graph and the motion map look like. Now, we've already done that for constant velocity type motion. We've already done that. So this first one should not be an issue at all. Now, for the other ones, for the ones with curves on them, this might be an issue because we have not really done a XT graph to motion map to VT graph interpretation. Now, I've been asking you to do that on those couple of worksheets so far. You've been asked to do that because there is a VT graph given, and you're supposed to sketch the XT graph and of course sketch a motion map. So we're kind of going the other way around. Now we're starting with an XT. We need to figure out what that looks like, VT, and figure out what the motion map looks like. So if you could indulge me here, pause the video here momentarily, and I want you to sketch what you think the VT graph should look like for this, and what you think the motion map should look like for this. Now again, this is like last unit stuff. This is like tumble buggy stuff. So pause the video now and then do that. Okay, I'm assuming you paused it, and now you're back. All right, so what we look at here, this says positive constant. What are we referring to? Oh, look at that. Hold on, I'm missing something. What are we referring to? We're referring to slope. And I don't know why this blue is not the same color as the other blue. I don't know. We're referring to the slope, which is referring to what? The velocity. Yes. Yes, very good, very good. Now, what does that tell us about this VT graph? How do you show positive constant velocity on the VT graph? Well, let's start with the motion map. Okay, where does the object start on the XT graph? It starts at the 0 position, and so we put our dot at the 0 position. What direction is it going? Well, it says positive direction with a constant velocity. Constant slope, which means constant velocity. That means we have to have arrows that are pointing positively, and they have to be constant length. Oh, look at that. The words here are telling us what the arrows should look like on our motion map. All right, back to the pen. Here we go. Oh boy, this is a bad motion map. There we go. There's the motion map. Now, I am going to add one more thing, which most of you have not been adding on your motion maps on the assignment so far. You've not been doing this. Pay attention. You must do this. A equals 0. In this case, there is no acceleration. So my slope here, oh boy, where's my pointer? My slope here is constant, which means my velocity is constant, which means I don't have an acceleration, no acceleration. This would have to be a curve. like that or that. No curve, no acceleration. Now, down to here. What did we say that positive constant velocity looks like? Again, this is old stuff, so you should know that that's up there like that. Parallel to the t-axis, but above it, because that's where the velocities are positive. Remember, they're positive up here, they're 0 here, and they're negative down there. All right, now, the VT graph on the next, or no, the motion map on the next graph. So, positive, increasing, because notice, the first tangent is not very steep. As time went on, the next tangent, much steeper. That means the slope of this curve is increasing. It's positive because it's tipped up, and it's increasing. And again, we're talking about the slope, which is velocity. So how do you show in the motion map a positive velocity that is increasing? Think about your arrows, pause the video, sketch it. And here we go. I'm assuming you paused it, and now you're wanting to see. So the arrows start very, very short. Well, first of all, oh gosh, it starts at the y axis. I mean at the, oh my gosh, at the 0 position. This stylus is not good. Very short arrow at first, and then the next second it's faster, and then the next second it's faster. Heck, one more second. Even faster. How about that? Now, the A in this case, we'll get back to that in a second, because we need to look at the VT graph to tell us that. We need to look at the VT graph that will tell us what our A is. Notice here, this was 0 slope. 0 slope here means 0A. 0 slope. How do you show on the VT graph a positive increasing velocity that starts with none? Like, there's no slope. This line, this curve on the XT graph starts off horizontally. It comes out from the origin here horizontally. All right, no slope. That means no velocity. No velocity. None. Where's no velocity here? Remember, that's 0. Those are positives. Those are negatives. Oh my gosh, my negative sign is all there. So, pause the video, sketch what you think it's supposed to look like. Do it now. Do it now. All right, and so hopefully you're back. It's starting the line. When I say it, I'm talking about the line is starting at the origin down here at 0 velocity, because that's how much slope the line had, the curve has at the beginning. And it's getting bigger. It's increasing. Positive. That's this. Okay? All right, that is telling us the velocity starts with none, and it's getting bigger as time goes. Bigger positively. Positive and getting bigger. I hope you see that. Now, we've already seen this curve before, because that was the go car that was rolling down the track. We've already seen that motion map, and we've seen this VT graph. So again, this should not be a surprise to anybody still. So the first two here have been review. We've seen these before. Next one. Now, look at the curve. The curve says, it's telling us that the tangent is positive. It's a positive slope. Remember, it's tipped up. This is also a positive slope, but it's not as steep. It's steep at the beginning. It is not steep at the end. Steep at the beginning, not steep at the end. What does that do? We look at these words here. It's positive, yes. It's decreasing. In other words, the steepness is getting less. It's decreasing steepness, which is decreasing velocity. How do you show on a motion map a velocity that is positive, but it's getting smaller? Now, I realize this line is going up, okay? The position's getting bigger, but the slope isn't. The steepness is what we're looking at here, all right? The steepness, because both these lines are going up. That's going up, that's going up. But I don't care what the line is doing. I care about what the slope is doing. And that steepness starts off really steep and it gets not steep at all. So pause the video and sketch what you think the motion map should look like, knowing that the lines or your arrows which are velocity, have to be positive, but they're decreasing. Pause it now. Do it. All right, I'm assuming you're back now. And I'm going to start my first dot at the origin. And again, how do I know that? Because it's at the origin at the start on the xt graph, the position time graph. And my arrow has to start what? Long. Why a long arrow? Because it's fast. And then it's getting less fast because the steepness is getting less. Oh, daggone Billy Mall. I forgot. We didn't do the A on the previous one either. All right, we got to go back. So the A on the previous one. Let's look at this. I'm sorry that I. Well, no. Okay, hold on. Oh my gosh. Let's just stick with one thing at a time. So we just did this. Okay, we said that the velocity was big, large, and positive, and it got less. It was positive, very steep at the beginning, and it decreased. The slope got smaller. How do you show a positive velocity that's getting smaller here? Positive velocity getting smaller. Where are the velocities positive again? Remember, that's 0. That's positive up there, and that's negative. Oh my gosh, are you kidding? That's negative. So, how do you draw a line on the VT graph that shows a velocity that is positive but decreasing? Pause the video, try it. Pause the video, think about it, try it. Okay, I assume you're back now. Positive and big is up here. And it's decreasing. The velocity is decreasing, getting closer to what? 0. That means it has to do this. That has to be the graph, the VT graph that describes what we just set up there. It starts with a positive, big velocity, positive, steep slope, and the value gets smaller and smaller all the way down to 0 sometime later. And again, how steep is this curve right here? Well, if we had a tangent all the way out at the very end, it's going to be nearly horizontal. And horizontal on this graph means not moving. No velocity. Okay. I know this can be extremely confusing. If you have to, play it back and listen to this stuff again, that's fine. Now, the one thing I kept skipping over and forgetting. We have to look here at this. That graph, this graph, see, this one, the slope of this one tells us what velocity is. The slope of this one tells us what acceleration is. That slope is what? How do you describe that slope? It's positive, right? It's positive constant slope, which is describing what? Our acceleration, which is positive in this case. Positive acceleration. Boom. You draw an arrow that's positive. Now look at this slope here. On this graph, we have a negative slope for the VT graph, a negative constant slope, which means our acceleration is negative acceleration. That's supposed to be a negative arrow. Oh boy, that's pretty bad. So, everybody got that? Does that make sense? Maybe? Hopefully? Maybe? Hopefully? Okay. I'm going to the next slide. Here are the final two graphs that we had on that worksheet. Again, hopefully you have that in front of you. And sorry, there are some other artifacts here. As I cropped and cut this thing apart, there's a little thing here and a little thing here hanging out from the other side of the picture when I cropped it. So anyway, same kind of situation, okay? We're looking at this curve here. This is a very interesting shaped curve. And what kind of slope does this curve have at the beginning? Tell me what the slope of that tangent to the curve is. I hope you're saying that it's very steep and it's negative. That is a negative slope and it's also steep. That means fast, right? Steep means fast and it's negative. So that's fast negative. As time goes on, what's happening to the curve? How steep it is. It's not getting steep at all. It's getting less steep here, right? This is flattening out to the point where if it keeps going, it's going to get like almost 0 slope. So it's starting off steep and negative, and it's getting less. So again, it's negative slope, but it's decreasing as we described before. And those words are what's describing slope, which are what's describing velocity. Now, pause the video and sketch what you think the motion map should look like for a velocity that is negative, but it's actually decreasing. Negative velocity, decreasing. And notice where the line starts here. Your position is not at the origin now. It's where? Ooh, I just gave something away. Pause the video, sketch the motion map. Okay, I assume you're back. You better have paused this and tried it yourself, dang it. All right, hold on. Let me get, am I still red ink? Okay. So, I'm going to draw my first dot out here. Why out here? Because it started away from the 0 position, all right? Away from the 0 position, traveling in the negative direction, and it's getting slower, meaning it's starting fast, and my arrows are now what? Getting smaller. And in fact, I'm probably going to have to, that'll probably be my last one, because where am I right now? I'm almost at the origin, which is where my line is on the graph. At the end of this time interval, my line almost gets down to the t-axis, and so my arrow gets almost to the t-axis, or the 0 position. Actually, it's almost exactly at the 0 position. Anyway, that's that. Okay, that is a negative velocity that is decreasing, starting with a positive position up here. Now, VT graph. How do you show a negative velocity that's getting smaller? Negative and getting smaller. And well, I'm going to remind you, 0 velocity here, positive velocities up here, negative velocities down here. So where does my line have to be? Is it going to be on this side of the 0 or on this side of the 0? Well, what did we just say? It is a negative slope. Negative slope on this graph means negative velocity. Those are down here. Negative velocities are down here. But it's decreasing. It's getting less. Pause the video and show what that you think that looks like. Pause it. Sketch it. Okay, I assume you're back. So, down here would be a negative pretty fast. All right? Now, where does the line go from here? That's the question. Well, you may not have thought this, but it goes this way. The line goes up, but remember, on this graph, it's going up toward what? Toward the 0. This is what's very confusing about VT graphs. The line is going up, but that doesn't mean the value is going up. The value is actually going down. It's decreasing because the value is going from a fast velocity, like negative 10 meters per second or negative 10 miles per hour or negative 100 miles per hour is still fast. It's just in the negative direction. And it's getting closer and closer and closer to 0. That means, again, it's slowing down. It's decreasing. But it's just in the negative direction that it's happening. I hope this makes sense. Now, I want you to look at that slope. What kind of slope is that? That is a what kind of slope? Positive. Again, I don't care where the line is. I want to know what the slope is. That's a positive slope. Well, what does that have to do with anything? Well, remember, the slope of this graph tells us acceleration. So when we go up here to our motion map and put our A that many of us have been neglecting, what direction is my A? Right there. Opposite direction of what the thing's going. Interesting. Interesting. All right. What's next? Okay, so now we've got the no. Hold on. So I want you to look again at this graph. This means the fact that the line is now down here tells us we have negative velocity. The velocity values are negative, which just means my arrows are this way. That means the object's going this way, negative direction. But my slope is positive, which means my acceleration is the other way. So there's two different things here that this graph's telling us. It's telling us the direction of the velocity by where the line is. It's telling us the direction of the acceleration by which way it's tipped. Okay, last one, finally. I didn't think we'd ever get there. So, last one, notice the first tangent. The first tangent is like horizontal. This line is coming out of the position axis like horizontally. That's not steep at all. That's that's level. That's flat. And then it's doing what? It's curving around this way, curving down, and it's getting steeper and steeper and steeper. And so notice that tangent is way steep compared to this one. Now, what kind of slope is this? Negative slope. That is the velocity. And it started out with none, and now it's getting very steep. That means the slope is increasing. The steepness or slope is increasing, but it's doing it negatively. It's increasing in steepness to the negative side, or to the negative way of being tipped, I should say. So now the question becomes, how do you show on your motion map a velocity of an object that starts, again, not at the origin, it starts where? At a position positive away from the zero, and it's going to be traveling in the negative direction and increasing in velocity. That's getting faster. Remember, decreasing velocity is getting slower, increasing velocity is getting faster, negatively and getting faster. Sketch it. Pause the video, sketch. Do it now. Okay, hopefully you're back now. And that means I will sketch my first dot out here at a positive position, and my arrow is going to be kind of short because it's not going very fast. And the next second, it's going a little faster. And then the next second, a little faster. And so on. Oh, you know what? I wonder if I can move those. I wonder if I can move them. Oh, look at that. I need to move them a little bit closer. And why would I do that? Because I didn't have room to fit a fourth arrow in there. And I need to get pretty close to the t-axis. Maybe it's not quite close enough, but it'll do. Because that line got very close to the zero position, which again is the t-axis, which is 0 here on my motion map. All right, now, again, we do not know what A is yet. I want you to think about, maybe you can predict what direction A has to be to make this motion map look like it does. Maybe you can't, I don't know. But, next question is, what does this look like based on what we've just said? It's negative velocity, but it's getting faster. It's increasing velocity. Now, remember, this is zero velocity right here. These are positives. These are negatives. Now, where did we say the line was? It's going to be in the negative area. It's going to be down here. How much velocity does it start with? Look at the slope at the beginning. How much slope does it have here? Slope here. Zero slope. No slope at the beginning, getting very steep. Did I already tell you to pause it and do this? If I didn't, then do that. All right, now, here is where my line is going to start on this graph. Oh gosh, that's not right. Here is where my line is going to start. No velocity. This thing starts not moving, but it gets faster negatively. How does the line have to go to get faster negatively? I hope you're thinking this. Oh, that line is not in the right place. Oh my gosh. Okay, that's a little better. All right, that is what that line should look like. Okay, that's telling us the velocity starts out with none, but it's getting faster negatively. I know the line's going down. The line is going down, but it says increasing. That's why you got to get it in your head, okay, that whenever the line goes this way, that's getting faster. Whenever the line goes this way, that's getting faster. Okay? That's getting faster when the line goes away from the zero. Anytime the lines go away from the zero, that's faster. Anytime the lines go toward the zero, like this or like that, anytime they go toward the zero, that's getting slower. Slower, slower. faster, faster. I hope that makes sense. Do you need to write that down somewhere? Slower. Oh, what the? Slower. 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 Faster. Faster. Okay. Okay. Repeat that. Rewind that. Listen to it again. And watch it again if you have to. If it helps. All right. Now, last thing. Oh my gosh. We're never going to get this done. This right here. What kind of slope is this? This is a negative slope. What does that tell you about A? A has to be, do that now before I do it. Write it down. A has to be this way. Now, I want you to notice something about all your motion maps right now. The A is pointing in the same direction as your velocity when it's getting faster. Okay? Think about that. I'm going to go ahead, because we don't have them all in front of us right now at the same time. I'm going to draw. So we had this one right here. We had a set of arrows that were doing this. Remember? We had one motion map look like this. And what direction was the A? It was that way. It was the same direction as the velocity arrows. Getting faster, 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 faster. This one, getting faster, faster. A, same direction. A, same direction. Now look at this one. What's happening to this one? It's getting what? Fast, slower, slower. It's getting slower as time goes on. It's getting slower. A is what? Opposite. Opposite direction of what it's going. Then now we had another one. Because again, there can only be four. If you think about this, there can only be four scenarios here. Because we also had something like this. Oh no. Oh, daggone Philly Mall. I started the wrong side. Oh my, I just did, I did it again. We started with this one. We had a long arrow. And then they were still positive, but they were getting shorter. Like so. And the A was what on this one? It was that way, if you remember. Oh gosh, that arrow is bad. It was that way. Now, what does that mean? Again, look at it, look at it. These two. Our velocity arrows are getting smaller, which means it's slowing down. Slowing down means the A, opposite direction as the velocity. Here, again, velocity slowing down, A, opposite direction. Here, getting faster, A, same direction as the velocity. Here, velocity to the right or positive direction, getting faster, A, same direction to the right, positive direction. Oh, now, I don't know if this helped anything or not. I really hope that it did. I will probably post another assignment at some point in a couple days and see maybe if you can try to figure some of this out on your own. In fact, I do have a worksheet that has these graphs on it that you have to sketch this graph and a motion map for curves like these. I may end up posting that one to give you some practice that you can try on your own, and I guess we'll kind of go from there. I hope you all are doing well. Things are quiet around here, hanging out at home. So again, I hope you're all doing well. Hopefully we'll see you at some point soon. Bye.